In this mini clip, we'll be discussing domain and range. While we answer this question together, you'll be solving the similar problem on your own using the same technique. We are asked to find the domain and range of f of x equal to sine squared x plus 5. Before we begin to answer this question, let's get a better understanding of our function. Sine squared x simply means that we are going to take all the values of sine x and square them. This is what this 2 means here. This will have a direct effect on our f of x or y value. Adding 5 will cause the graph of sine squared x to move vertically upwards by 5 units. Again, this will change our value for f of x or y. Let's begin by finding our domain. To find the domain, we need to consider the minimum and maximum values for the variable x in our function. Looking at our equation, we will realize that we are dealing with the sine function. So let's take a closer look at the sine function because this will help us find the domain and range for the function given to us in the original question. Hopefully we are all familiar with the sine function. Here is just one period or one cycle of the function. This graph will continue in both the left and right directions. You will notice that for every x value, so the x values are found along here, there exists a y value. Therefore, for our graph y equals sine x, there is no restriction on x. It can go from negative infinity all the way to positive infinity. Now looking at the function where we want to find the domain for, I mentioned that by squaring our sine x graph, this will have a direct effect on our y value. And same with adding 5. It has an effect on our y value, not our x. So our domain for sine squared x plus 5 is actually the exact same domain as our function sine x has. So we just need to write this out in proper notation. We have d for domain, colon, squiggly brackets. Now for domain, we're looking at our x variable, so we have x such that we have no restrictions on x, so we will write x belongs to all reals. And we're going to close the bracket. I would now like you to find the domain for the question you were given. Here's the answer you should have got. Coming back to our question, now let's find the range. The range depends on the smallest and largest value that f of x or y can be. Now, to find the range, we're going to look at our function in different parts. We're first just going to consider sine squared x. We're going to find the range of this function first. Now, I mentioned earlier, to draw the graph of y equals sine squared x, we would have to multiply all the y values of the graph of y equals sine x by themselves. We only want to deal with the maximum and minimum values of y equals sine x because we want to find the range for y equals sine squared x. So we're just going to look at these key points, the maximum and minimum values. You'll notice that for the graph of sine x, we have a maximum value of positive 1. Multiplying this by itself, so 1 times 1, will also give us positive 1 in our y equals sine squared x graph. So our sine squared x graph will also have a maximum value of 1. Now let's consider our minimum value. For our sine x graph, our minimum value occurs at negative 1. Multiplying negative 1 by itself will give us positive 1. So we're probably going to have a different minimum value for our graph of y equals sine squared x equation. In fact, Since we're squaring all the y values of the graph y equals sine x, we will only have positive y values in the graph of y equals sine squared x. Therefore, the lowest y value in the graph of y equals sine squared x has to be 0, since we cannot have any negative values for our y variable. Therefore, our range for sine squared x is between, just going to write between here. We know that it's going to have a minimum value of 0, and it's going to have a maximum value of 1. Now we're going to add 5 to sine squared x. Now we're going to find the range of this function based on the information we found in this previous line. I mentioned earlier that adding 5 to sine squared x will cause the graph of y equals sine squared x to move up 5 units. Therefore, to draw this graph, we need to add 5 to all our y values in the graph of y equals sine squared x. And we only want to consider our maximum and minimum values because we're finding the range. This means that our maximum and minimum values for the function sine squared x plus 5 would be 5 and 6. I just added 5 to the maximum and minimum values of the graph sine squared x. So we have that for sine squared x plus 5, we know that it will be between 5. All I did was I added 5 to the 0, the minimum value of sine squared x, and 6. Adding 5 to the maximum value of sine squared x. And this will be our overall range. We just need to write this in proper notation. So we will have r colon squiggly brackets. Now for range, we look at our y variable. So we have y such that, and we know that it goes between the values of 5 and 6. So we will have 5 less than or equal to y, which is less than or equal to 6. Then a comma, we need to show that y belongs to all reals. And we're going to close the bracket. I would now like you to find the range for the question you were given. Here's the answer you should have got.